Hello everyone, this is Dr. Shaha. Today I am here to discuss about the very basic of circuit theory, just like how the current flows through in different kind of circuit connections and what amount of current flows through and all. So let's start with very simple and basic design of series parallel connection of resistors. When two resistors are in such position or in such kind of connection, the same amount of current flows through R1 and R2 resistor. There is no splitting up of current. There is no obstacle in between this R1 and R2 resistor. Same amount of current flows through R1 towards R2. Then they are called in series connection. And we can find the equivalent of this R1 and R2 by simply taking the summation of R1 and R2. Okay, so remember that same amount of current flows through R1 and R2. When R1 and R2 are in such kind of position that there is an obstacle or knot in between them and current flows through and it gets split up and flows accordingly, then they are called in parallel connection, and we can find the equivalent by using this formula. Sometimes it becomes very difficult and confusing during complicated circuit analysis. So if we are very clear about the current flow pattern, how current flows through in series parallel connection, then it will be easier to analyze during the complicated circuit. So we can compare the flow path of current with the flow path of the river. So however, we know that water flows through a river, and what happens when there is an obstacle in between the flow path of the water. So let's see, there is a tendency of river flow that it changes its flow path very often. When there is an obstacle and big obstacle in between the flow path of river, that it just splits up and flows accordingly. River water started to flow from the mountain, so here the voltage source we can take as a mountain, and they flows accordingly, and when they find any kind of node as obstacle, it just gets split up. We can take the ground side as the sea level. We can assume that the flow path of R2 river touches the sea level, and we can assume that it stops the flow as a river here. And again R3 flow path find an obstacle and it just splitten up and flows accordingly. But we can see that in R4, R5 and R6 same amount of current flows through, although it changes its flow path, but there is no splitting up in between them, there is no knot, there is no obstacle, so they are in series, and we can take the summation as the equivalent of R4, R5 and R6, and we can replace the resistor with a single resistor. So again water start to flow, find an obstacle, it gets splitting up and flows accordingly, find obstacle, splitting up, flows accordingly. Here R4 and R5 6, here the current splitting up and flows through, that means they are in parallel connection. And we know the formula, I've shown the formula in previous slide, that when two resistors are in parallel connection, how we should take the equivalent. So we can simply replace the resistor with the combination or equivalent of this 3R4 and R5 6. So again flows, splitting up, flows. Here R3 and R4 5 6 same amount of current flows through, so they are in series connection. Again started from the peak of the mountain, flows, find obstacles, splitting up. So here R2 and R3 4 5 6 are in parallel connection, so we can replace again in series connection, and we can replace by taking the summation. And finally we get the most composite resistor of all the resistors equivalent as R1 2 3 4 5 6. So this is the flow path. So when we should use this kind of concept of finding equivalent resistor, we will see it in next session. Thank you.